Hello everyone, this video is on solving problems involving acute triangles. Before we begin solving triangles, or problems with acute triangles, here are 5 things I think that it's good to know and they'll help you while we're solving. Number 1, sine law. Well, you guys are pretty good with that right now. Cosine law. General triangle or angle information or knowledge. So this is stuff you would have gathered or learned in the previous chapter. Things I'm talking about, maybe that the 3 angles of a triangle add to 180 degrees, our parallel line information. If we got parallel lines, we know this line, those 2 angles are equal, that sort of thing. Alternate tier angles, by the way. The Pythagorean theorem, again, a squared plus b squared equals c squared. You guys have known that one for a long time. And then sine, cos, and tan ratios. So in grade 10, you would have learned these. We have the acronym SOHCAHTOA. That helps you remember these. It's that made-up word. And in case you do forget, sine is opposite over hypotenuse. Okay, that's what the O and the H stand for in SOHCA, or in SO. Cosine is adjacent over hypotenuse. And tangent, opposite over adjacent. All right, so these are 5 things I think if you can remember this, it'll help you a lot when we're solving these triangles. One last thing we should look at before we start solving these problems is compass directions. In this textbook, they have problems where they use compass directions to try to help you diagram the situation. So an example of what I'm talking about would be north 20 degrees east. So what they mean by this, well, first of all, you got to remember your compass directions. So I just like to draw this, and remember this is north, south, east, west. Never eat shredded wheat, whatever kind of acronym you learned as a little kid. And north 20 degrees east means we go along the north line, but then we have to veer off 20 degrees in the east direction. So in the east direction, I'm going to go 20 degrees over. So that's the line they're really talking about. Let's do another one. Pick my color. South, 40 degrees west. Once again, let's get our directional lines here going. North, south, east, west. Okay, so this is saying we're going to travel along the south line and then veer off 40 degrees to the west. So we don't have to be exact, just put it in kind of an area, but we have to have this exact number. So you can see I'm moving 40 degrees over into that west side. Another one. North, 35 degrees west. Directional lines. You're going to see me draw these in the problems as well. I think they're just easier. Okay, so we're going to travel along the north line, and we're going to veer off into the west again. Oh, I forgot to put my little headings. North, south, east, west. And it's going to veer off into the west, and we are veering 35 degrees off of that north line. Final one, you might not need it, but I have it, so let's do it. South, 60 degrees east. Drawing my directional lines, north, east, south, west. This says I'm going to travel along the south line and veer 60 degrees east. So that's going to be something like that. If I think 60 degrees, that's pretty big. 60 degrees east. All right, so that's compass directions. You're going to see those in some of the problems. If you understand it, they're not that bad. If you need help, make sure you come find me. All right, first problem. In these problems, if they don't provide a diagram, you have to create one. The diagram really is all the work. Once you get the diagram, you're going to use sine law or cosine law, and you're good at that right now, so the solving won't be tough. It's going to be the creation of the diagram. So, example 1. A canoe leaves a dock on Lake Clare and heads in a direction north 71 degrees east for 1.9 kilometers. Good thing we practice these. At the same time, a second canoe travels in a direction south 28 degrees east from the dock for 3.1 kilometers. What is the distance between the two canoes to the nearest tenths? All right, so first thing I'm going to do, we have these directional things happen, so I'm going to make my directional lines. North, south, east, west. You don't have to put that much detail into it if you don't want to. All right, so we're going to go in my first directional description, north 71 degrees east. So I'm going along the north line, and I'm going to veer off 71 degrees to the east. So just a little reminder, remember this is 90 degrees here. So if I'm veering off 71 degrees, it's going to be kind of fairly close to that east line, I guess. 71 degrees. Now, when you do that, remember, we don't need scale. We don't need to have it perfect. I'm not breaking a protractor out and measuring these things. We have to have the right numbers, though, and be in the right direction. Okay, and we traveled that for 1.9 kilometers. The second one, south 28 degrees east, and it's from the same dock. So I'm traveling the south line 28 degrees east, so that's not as east as the other one. So I'll say here, again, it doesn't have to be perfect. 28 degrees, I'm going to make the 28 over here and put my little arrow. All right, and I could actually even extend this one a little bit because it's supposed to be a little bit longer. It says it went for 3.1 kilometers. And then now I have two sides of a triangle. I can connect that up. Okay, so that's part of my drawing. So I can see I have two sides, one here, one here. What I need is at least one more side or angle. So if you look around, again, knowing that that is 90 degrees, that's going to help me in this situation because right here is going to be 90 degrees as well. So the portion inside the triangle will be whatever 71 plus something equals 90, so whatever the difference is. So that ends up being 19 degrees. So I know that's 19 from here to here. And then it's 28 degrees over on this one. So 90 minus 28, 62 degrees. This ends up being 62 degrees. So when you're drawing these diagrams, sometimes they can get messy. So often I'll kind of sketch something out, and then once I think I've kind of got a good thing, I might redraw it. So I think I am going to redraw this one. And I'll just redraw it right down here. And again, it maybe doesn't look perfect now, but it's the right idea. I have to add these two together. Okay, so that is 70, 81 degrees. So this will be 81 degrees. And this is 1.9. And this is 3.1. Okay, the next thing I should do is get my little, well, I like to number these, or sorry, letter these, label them. That's the word I'm looking for. I want to label this. What do I mean by that? Okay, well, I mean, I'm going to call this A, B, C. And then what I'm going to do is I'm going to break out this little setup step. You know, if you've watched my review video, you know I do this. And start naming things. So angle B I know is 81 degrees. Side A is 1.9. And then side C is 3.1. I have also noticed, this is kind of funny, that this one is actually more messy than this one. But there's not as many numbers. So hopefully it is a little bit clearer to see. So often I'll sketch something out. If it looks like it's kind of tough to read, I'll redraw it so it's easier for me to read. Now, back into the question. I've noticed that there is no row. I don't have a completed row, so I can't use sine law. That means I use cosine law. And reminder, we are looking for this. This was the first canoe up here. This is the second canoe down there. I want the distance between the two canoes. So that ends up being side B. So for cosine law, that's what I'm looking for. So B squared equals A squared plus C squared minus 2AC times cos B. All right, so here, hopefully solving isn't a big deal anymore because I'm going to go through this a little bit faster, the solving. I won't show as much work because I'm anticipating that you know how to do this now. All right, so I go 1.9 squared plus 3.1 squared minus 2 times 1.9 times 3.1 times cos of angle B, which is 81 degrees. Again, reminder, you kind of have two things. You're going to have a grouping here, and then you're going to end up having a grouping here when we're doing crunching our numbers. So 1.9 ends up being 3.61. 3.1 ends up being 9.61. And when I multiply the negative 2 times 1.9 times 3.1 times cos 81, I end up getting actually a really small number, 1.84. Be sure your calculator is on degrees when you're working with this. All right, when I add that up, I end up getting 11.38. Now remember, that's b squared. I want b, so I take the square root of that. B ends up being 3.37. They ask for rounding to tenths, so 3.4, and I'm assuming this must be kilometers. Yep, it's kilometers. That's my answer. The canoes are 3.4 kilometers apart. All right, so again, the solving was easy. The diagram is everything. Let's look at another one. A vertical pole of length 8 meters is located on a hill that is inclined at an angle of 21 degrees with the horizontal. I'll show you what that means in a second. The pole is supported by a wire of length 12 meters that is attached to a stake in the ground that is directly uphill from the pole. What is the angle between the wire and the hill to 2 decimal places? Okay, so we don't have the compass directions here, so that part's a little bit easier, but understanding what's going on might not be. So we have a hill. Oops, that's supposed to be black. We have a hill. What is going on here? Let's try it one more time. There we go. We have a hill, and it's inclined at an angle of 21 degrees with the horizontal. So what that means, if you draw a horizontal line, that's just how they're measuring how steep the hill is. So if you made a horizontal line out in nature and then you measured up from it. So that's how steep this hill is. Now we have a pole that is vertical, so I'll put it right there. It is supported by a length of wire that is 12 meters and is attached to a stake in the ground that's directly uphill from the pole. So I know if it's uphill from the pole, it has to be that way. So I'll just say it's kind of like right here, and I'll draw my line. So you can see there's my triangle. Now remember, when we're doing this, you can draw as many horizontal lines as you wish, because this was an imaginary horizontal line. There aren't really just horizontal lines next to hills if you go for a little walk. And seeing these are parallel to each other, I know that this is 21 degrees as well. I also know it because I could have just done my measurement, my initial measurement from there. Meaning, I could have done something like this right away off the start. Okay. Anyway, back to my drawing. Notice that it said it was a vertical pole. So if it's vertical, then I know that this is going to be 90 degrees with that horizontal line. So like the previous problem, this angle here is going to help me get this angle there. So 90 minus 21, so that's 70, 69 degrees. So I know that this part is 69 degrees. I didn't put all my measurements in. I know the pole is 8 meters. What else? And the length of the wire is 12 meters. So now I have 3 pieces of information. Once you have your 3 pieces of information, now it's time to determine what sort of solving method I'm going to use. Sine law, cosine law, like what's it going to be? So angle A, angle B, angle C, A, B, C. I like this setup. Again, you don't have to recognize if it's side, angle, side, and all that sort of thing. Doing this helps you out. I don't have any letters on there, so you just throw letters in. It doesn't matter where you start. So this is A, this is B, this is C. You can't go wrong there, all right? You throw in the letters wherever you want. It all balances out. So angle A, we said, ends up being 69 degrees. Side A ends up being 12. And then what do we got here? Oh, side C, that's 8. So side C, remember that the side is, the way they name the side, sorry, if this is angle C, then across from it is side C. Just wanted to remind you of that. Okay, when I look at my setup, I can clearly see I have a row, meaning I can use sine law. All right, and then what am I looking for again? What is the angle between the wire and the hill? So I'm actually looking right here. So that ends up being, I'm sorry, I meant to actually use another color there, so it stood out a little bit right here. Ends up being angle C is what I want. I want to know angle C, so I'll put a little question mark there. All right, so you can use a sine law however you want to do it. I'm going to use it the way I like to do it, one of my Troyisms. I like to put whatever I'm looking for in the top left, And that way I have a little bit easier of a time solving. Instead of cross multiplying, I can use that pattern like I showed in that review video. All right, so sine C over 8 equals sine 69 over 12. Okay, and then I'm just going to actually do the partial multiplication, not the full cross, just half of it, for reasons I've discussed in a previous video. All right, so it's going to be 8 times sine 69 all over 12. And if you didn't watch that video and like, what the heck's going on, it's because if I multiply that over, that's great, I'm going to end up dividing it back over. So the 12 actually moves and comes right back to where it was. All right, and then I don't want sine C, I want angle C. So to do that, now I have to take the inverse sine of this. And I don't like carrying decimals or anything, so I'd rather write all this out and just do one calculation at the very end. All right, so I'd grab my calculator, I work it out, 38.49 degrees. Perfect. Okay, once again, if you can draw the diagram, the solving's easy. It's all about the diagram. And the only way you get better is by practicing, by doing a lot of them. Let's keep moving. A tree is growing on a hillside. The hillside is inclined at an angle of 15 degrees to the horizontal. The tree casts a shadow uphill. How tall is a tree to the nearest meter? All right, well, this is nice. You can see we have a diagram. Sometimes, however, diagrams aren't totally complete. You still need to add some information into it. In this one, I think we're going to. So I'm going to actually redraw this quickly, just so it's going to be easier to add some details to the drawing. So here's my horizontal line. Here's my hill. Here's my tree. Here's the sun. So now what do I know? I know this is 15. I know, oh, I actually forgot another horizontal line. So I have another horizontal line here. Go back to putting information in. I know this angle here is 57 degrees. And I also know this distance here is 7 meters. Okay, so that's everything I got. You don't really know if you need more information until you start to kind of think about how to solve it. So if I call this guy A, this B, this C, I'm going to do my little setup. That helps me determine, is it sine law, is it cosine law? And I'll see what I got. And it'll also tell me, if I only have 2 pieces of information, it'll tell me, well, you need more information, because you always need 3. So I know angle C is 57 degrees. I know side B is 7 meters, and that's actually all I know. So I'm going to have to find more information. So maybe that's a side length, maybe that's an angle. So you start to examine the diagram and look for things. And what you'll notice is that, well, I have a horizontal line up here and a horizontal line down there. They must be parallel to each other. Why must they be? Because horizontal lines are always parallel to each other. Just like vertical lines would always be parallel to each other. So I have parallel lines. I'm going to look for some sort of relationship. And here, you can notice that where I put the green, those are alternate interior angles. How? Okay, well, we have these parallel lines like I discussed before, and then we have a transversal. The hill ends up being your transversal. So that's telling me that this is 15 degrees. And if that's 15, I guess then my 57 minus 15 ends up being 42. Okay, well, what else? Well, I know that we have this tree, and in this picture over here, that tree looks like it's straight up and down, so this is going to be a vertical tree. Why is that helpful? Well, why that's helpful is that because now I can see I have one triangle here and 2 triangles, a second triangle there. I can use my angles in a triangle add to 180 rule to help me figure out the missing angles. So like in this top, the first triangle, 90 plus, so I use subtraction. 180 minus 90 minus 42, that means this ends up being 48. And then on the bottom triangle, 90 minus 15 ends up being 75. So I went from not having enough information to now having lots of information, more than enough. Oh, I put that in the wrong spot. 75 degrees. This is 48. I'm just going to scratch this out because last time I tried using the eraser, it erased all my work. So I don't want that to happen again. Okay, now what am I actually looking for? I'm looking for how tall the tree is. So that would be side C. Okay, so you can see I have a row. I can use sine law. Let's get rolling with it then. Again, I like putting what I need in the top left, so I'm going to say C over sine C equals B over sine B. Hope I left myself enough room here. C over sine 57 equals B, which is 7 over sine 48. I can do my half cross multiplication because I've done my little trick where I put my unknown on the left. C then equals 7 times sine 57 all over sine 48. All right, and then when I start crunching my numbers, I get 7.9 meters. Okay, so we had a diagram which looked nice, but then we had to add some more information. And then to get that information, I had to use my parallel line knowledge. So this stuff does build on each other. All right, I know it's getting kind of long, but let's look at one final example. Ryan is in a police helicopter, 400 meters directly above the Sea to Sky Highway near Whistler, BC. When he looks north, the angle of depression to a car accident is 65 degrees. When he looks south, the angle of depression to the approaching ambulance is 30 degrees. How far away is the ambulance from the scene of the accident to the nearest tenth of a meter? All right, because we're talking about angles of depression, then that means we're going to take a side view of this situation. If we took a top-down view, we wouldn't see an angle of depression. An angle of depression is simply an angle down, and you'd have to be on the side to see it. So, we got our man up in the police helicopter. They're talking about these angles of depression. The way you measure them is against a horizontal line. So that's popped up in a few of these. Whenever you're measuring an incline or a decline or an angle of depression, you need a horizontal line to compare it to. All right, so also just so you know, this is going to be north, I guess, and this is going to be south, just to give some direction to what we're doing here. So it says when he looks north, the angle of depression to a car accident is 65 degrees. So he's looking at the first car accident. It's the angle of depression, so it's the angle away from the horizontal line. Okay, is 65 degrees. When he looks to the south, the angle of depression to the approaching ambulance is 30 degrees. All right, so that means it's going to be kind of further away. That's not perfectly straight, but again, it's an angle away from the horizontal line, so that's 30 degrees. And then now, I'm going to connect that up. Okay, so the other thing we're missing here is that we know Ryan is 400 meters directly above the Sea to Sky Highway. So Ryan is 400 meters up. Now I put a little 90-degree sign because whenever you're measuring a height, that's always a vertical distance. So it's going to be perpendicular to the ground. Sorry, it's vertical. And then the ground in all your textbook problems, the ground is always horizontal unless stated otherwise. Okay, so what I feel we should do now is I want to label some things. So I guess I could say Ryan, and we could say car crash, and this could be ambulance. And then I want to make my little setup because I want to see, do I need more information? So angle A, I don't know. Angle B, that'll be angle R. And then this can still be C, so I gotta make that an R. Again, I'd use the eraser, but it sometimes messes up on my laptop and it erases everything. Okay, so angle A, I don't know. Angle R, I don't know really. Angle C, I don't know. Okay, well that's not so helpful so far. Side A, don't know it. Side R, don't know it. Side C, don't know it. Okay, so I don't have a lot of information, so I need to do some more. Okay, so, well, one thing we can do is, again, this is general triangle knowledge, is I get to use my parallel lines. So like I stated before, this is horizontal and the ground is always horizontal, meaning this 65 here is also going to be put, get back to my black here, is also going to be down here. Whoa, 65. So this and this are equal. How are they equal? Those are alternate interior angles again. And then once I have that, if you notice, you could split our diagram again into two triangles. This being the first, this is the second. In my second triangle, I could figure out that third angle by going 180 minus what I know. So if I go 180 minus 90 minus 65, I end up getting 25 here. On the other side, I could also figure that out now too. Same idea. This has to be 30. Why? Alternate interior angles. And then now that I know that, sorry, I've got some hiccups here. Now that I know that, I can use my 180 rule. So 180 minus 90 minus 30 equals 60. Whoops, got green there. Okay. We can then, that's angle R. So once I add that together, that's going to equal 85 degrees. That's 85. So we got something. Hooray, we got something. 85 degrees. Okay, so that's starting to get kind of ugly. I totally realize. Before we move on, I guess we also have angle A. That is 30 degrees. So we got two things. We need one more thing, and then we can actually solve this. The way we'll get that one thing is, again, we're going to look at the smaller triangles within the 1 and the 2 angles. What we have there are right triangles. So with right triangles, maybe we can use sine, cos, or tan to help us out. So I'm just going to redraw triangle 2. I could use triangle 1 as well. I don't know why I said triangle 2. I just said it, so I'm going to roll with it. Okay, so this is Ryan. This is 90 here. This is the car crash. And this is straight down. I'm just going to make it a B, kind of random, but I'm just going to make it a B. We know that's 25 degrees. We know this is 65 degrees. We also know Ryan's height is 400 meters above. So what I need to do is I need to figure out, if I go back to my original drawing, I'll just draw your eyes back here, everybody. I need to figure out either this side, or that side. If I do that, I can then use sine law or cosine law. Sorry, I stumbled on my words there because I also noticed that I missed one. We also know the 65 degrees down here. Now, so I do have 3 pieces of information, but angle, 3 angles, that doesn't help you. I need one side length. So seeing I drew triangle 2, the easiest thing to find then would be right here. I can find side RC, which corresponds right here. That would give me my side. Then once I have that, I can use cosine law or sine law, whatever. We'll have to look again, and we'll be good to go. So now, which sine ratio? Again, when you're dealing with this, remember SOHCAHTOA. All right. So when you're dealing with this, you could actually do this a couple ways. You have to pick a corner to start from. So this is my 65. That is then opposite. That is the opposite leg. Okay. Adjacent is right beside, so that's across. That's opposite. And this ends up being the hypotenuse. So I need opposite, which would be here and here. And then I need hypotenuse. That's only there, so I'm going to end up using sine. So really quickly, I can go sine theta equals opposite over hypotenuse. So sine 65 degrees equals 400 over x. And then the way I solve this is I just make the left side a fraction as well. I put it over 1 because it's a value, it's just a number. And then I cross multiply. So I'd have x times sine 65 equals 1 times 400, so 400. And then I want x by itself. I don't want both, I want it by itself. So to move something to the opposite side of an equation, you have to do the opposite operation. Right now it's being multiplied. So I end up dividing. Okay. So x would equal to 400 divided by sine 65, and you get kind of a strange number, I guess, 441.35, and that would be meters. So that is this is that. That's a good CVC program, by the way. And then, so that ends up being side A. So side A ends up being 441.35. All right, so now I have enough information. I have 3 angles, which is good, and usually only need 3 things, but of those 3 things, 1 thing must be a side. So we had to get an additional 4th item, and you can see I've got a row, so this is nice because then I get to use sine law. It's a little bit shorter, not like cosine law is really tough. So anyway, this ended up being my first calculation, now my second calculation, and sometimes that happens. You have to make 1 or 2 calculations before you make your main calculation. Once again, what am I looking for? We never really talked about that over here. I'm looking for side R, okay, the bottom here, the distance between the ambulance and the car. So R over sine R, A over sine A. Start plugging everything in. Sine R over sine 85 degrees equals A, which is my 441.35, over sine of angle A, which is 30 degrees. And because I've set it up kind of smart, I only have to do half my cross multiplication. R equals 441.35 times sine 80 divided by sine 30. All right, crunch numbers now, get out your calculator. Again, if your calculator doesn't make sense to you, talk to a teacher, talk to myself. We got to make it make sense. Make sure it's in degrees. I get 879.34, I guess just 3/10 of a meter, just 3 meters. So it's 880 roughly meters away, that ambulance. All right. That was a long video. I'm sorry for that, but we had a lot of things to go over. So if it doesn't make sense, make sure you maybe try to watch the video again or come find me, contact me somehow. I hope it helps. Have a great night, everybody.